A very good afternoon to all of you. It's a real pleasure to be here sharing with you what's happening on electric vehicles, what are we doing, and how do we see the evolution and future of EVs. A very quick vote of thanks to the team who's made it possible. Please go on. This is me. I look after the product line for passenger electric vehicles at Tata Motors, and this is the team who have supported me on this presentation. I would thank Sarang Shirsagar, Shripad Pongshe, Chandrakant Avte, and Mayur Kulkarni for having helped me put up all this material together. I would say that I'm less of a material engineer, more of a vehicle engineer, but I will help explain whatever we have done, how we have done, and hopefully that is of great interest to all of you here today. Starting off, I would say that let's look at what's happening to the domestic automobile scenario in India. You see, India is one of the leading countries in terms of GDP growth, which will also lead to a higher car penetration in the coming years. And yet, we are just at the bottom of the pile when it comes to number of cars owned per 1,000 people. You can see that drawn by a small circle, and therefore we have reasons to believe that we would grow significantly in the future. You look on the right side, you see we were an industry headed towards 4 million. I think there's a small correction there. It's 4 million, not 40 million. We were headed towards an industry of 4 million. Of course, last year the blip happened due to COVID, but we have recovered well. And we are therefore looking at FY27 to be in the ballpark of 4 million cars annually. So increasing car densities typically bring a host of problems. And we are all familiar with this because India also shares a very dubious distinction of being home to 10 out of 20 most polluted cities in the world, including, of course, New Delhi, where 4 out of 10 people suffer from some kind of respiratory problem or other. So increased car density brings along traffic congestion, which then brings along pollution. Of course, we have road accidents. And in the case of India, you also have the situation of most of our oil imports being dependent upon geopolitically sensitive countries around India, and therefore there is a huge dependence on imports from a very sensitive area coming forward. And therefore these are significant problems that we have with increasing car density. Now, therefore, the question arises: how can we improve air quality? What can be done about it? Who does it? Does the government do something? Do we do something? Does industry do something? I think the answer to this is that all of us have to contribute to make sure that air quality and improvement of air quality can happen. So I've just laid down. This is a very deep topic in itself, but that's not what we are discussing today. So I've just laid down some core principles. You see, you could improve air quality either through standards, which is BS3, BS4, BS5. Now we are at BS6. You could also improve consumer awareness with the help of star labels. Most of our home appliances today have star labels on them to indicate how energy efficient they are. Or you could drive that to governmental policies and incentives in terms of a fee bait, meaning you apply a fee if you are polluting, but you also give a rebate if you are clean. You could also give credits. You could therefore use mobility as a service rather than individualized transportation, and you could drive faster adoption and of manufacturing of electric vehicles, which is called FAME, in order to improve penetration of electric vehicles. So electric vehicles therefore becomes a very, very pertinent product or a pertinent tool in order to improve urban air quality in our country, specifically to our country. And some of the reasons that we say so, because it's a green product, green as in that it is virtually a zero emission vehicle, a zero emission product at the tailpipe. We also talk about green fuel, and there's a lot of debate on whether this fuel or the electricity is green or not, for the simple reason that one might argue whether you burn fossil fuels at some other corner and create electricity and bring that back. But suffice it to say, and a point for another debate, but even when you have electricity being done out of fossil fuels, the efficiency of burning that in your vehicle or utilizing that in your vehicle is far superior than what you would have out of fossil fuels. Of course, the situation becomes significantly better if you have a basket of power, some of it coming through renewable sources and some of them coming through the traditional sources. But eventually, India is well on its way to have a good mix of electricity coming from a clean basket. Of course, and then there is a point that we all need to look at today. The industry is looking at environmental sustainability. How do we continue this? How do we sustain ourselves? What are the materials that we use? Does most of it go into landfills? Do we take care of toxicity, toxic materials, etc.? And we'll talk about that a little down the presentation. A very quick snapshot to sort of try and explain our audience today on what is the uniqueness of electric vehicles vis-a-vis the gasoline vehicles. And on the left hand side, you will see that one of the reason or one of the primary outcomes is that the weight of the vehicle increases, and that's on account of the batteries, which today are a fairly large component of the weight of the car. So electric vehicles tend to be a little bit more heavier than gasoline vehicles. Whereas on the other side, you also see in the right bottom that there is a difference to the mass distribution of the car. So if your ICE vehicles are weight biased towards the front, there's a small shift of the weight bias towards the rear end of the car, primarily because you have batteries there. And then, of course, you have the positives of no tailpipe emissions. You can have a significant cost reduction in terms of how much you really need to spend in order to go that 1 kilometer or your drive. And of course, this is balanced by what some people say as range anxiety and the time to charge. But this is a rapidly improving area where a lot of top dollars are being spent today in order to make sure that cars become faster, cars charge faster, and they're also able to retain their charge better. So if you see what's happening in EV aggregates, the key drivers so far as we are concerned are we're trying to extract energy and we're trying to utilize that energy from every watt of electricity that we have on board. So we are looking at very, very high efficiencies. And just to give you a number, for example, a traditional internal combustion engine would be about 33% efficient in terms of its conversion from liquid fuel to mechanical power available on the road. Electric vehicles are very efficient. They start off at being 92% efficient, and that's a significant improvement. Of course, we constantly have this challenge of system costs. Costs need to be driven lower. Consumers need to have better charging conveniences, and this is being achieved through higher energy density, higher power density batteries, higher energy density motors. And of course, as customers, we all would need to have the required degree of reliability, safety, and comfort. So this is what is happening. I've listed down some of the important developments that are happening in three key components, three key areas of batteries, e-motors, and power electronics. And you see, it's all about refinement. It's all about making sure that the mechanical design of components happens better. There are more batteries, high energy density batteries, and this is what the entire challenge is about today. At the same time, as I said, driving down costs. So this is an anchor slide so far as I'm concerned, and I hope we are able to explain this. For meeting all the objectives that we have spoken about in the previous slide, it is very, very important for us to make the right choice of materials. And when we make the right choice of materials, I have tried to list down the periodic table here. And if you look at the areas that I've shown in bold lines, there is one area which is top right, going down to the center and then having a small extension towards the left side. And of course, there is materials between the two parallel lines on the first row of materials. These materials are essentially what would normally get used in cars or vehicles, and they are the standard lot of materials like copper, iron. You would have aluminum, you would have zinc, you would have magnesium, and all of these materials being utilized for traditional vehicle making. When we look at electric vehicles, of course, along with these, we also have two additional specific materials that come into play, and they are lithium, which is on the top left, which is one of the core constituents of any battery cell. And then on the bottom side, you have the lanthanides, which is essentially the rare earth metals. And rare earth metals basically get utilized in traction motors in the form of magnets, either neodymium or dichromium, or these kind of metals get used in order to drive efficiencies at the motor level, which in turn becomes the driving factor for electric vehicles' power and performance. Now, while we do this, a lot of effort is being spent today uh, in terms of material science expertise, advanced testing capabilities. You would need a whole lot of technical support in order to start with bench-to-bench collaboration, etc. And this is where the industry is today focusing on leveraging insights and technology expertise, right? So let's look at you now fairly. I hope we've understood what an electric vehicle is and how the materials would be used. If I were to, at a very, very top level, say that an electric vehicle needs to have, apart from, of course, the traditional materials that we use on a normal ICE car, the material properties on electric vehicles may have certain specific properties. And what are those certain specific properties? One is mechanical integrity. The second one, most important, electric isolation. I heard Rajesh say that a lot of things have happened on thermal management. Yes, indeed. And for various reasons, thermal management is an extremely, extremely important part on electric vehicles. Of course, these materials should lend themselves to great assembly, quick assemblies, and the wear qualities on them should be in line with what you would expect out of a car, which has to run for at least about 10 to 15 years on normal life on the roads. So along with all the other materials that we looked at in the periodic table, some of the more advanced or the recent materials that we use are polyamides, PA6 or PA66 or PA610, or phthalamides, PPAs. And I haven't listed here, but there is also polyurethanes being used a lot. Of course, along with this, there is a whole new generation of materials which are used for thermal management, which are used for surface coatings, which are used for efficiency improvements, and we'll come to that shortly. So just a listing of some of the battery components and how these components come together and what are the properties. So within a battery, you can understand that the battery is not only a battery. There are a whole lot of componentry inside the battery. So you have disconnector units, you have junction boxes, you have bus bar holders. The batteries themselves would need to be secured into place in the pack by using some adhesives. There are breakers and switches and module housings. Now, each of this component has to meet a certain property expectation requirement of heat, vibration, and the ability to withstand long usage. And therefore, you need stiffness, you need thermal stability, you need it to be efficient, you need to be a damage resistance, high mechanical strength. Most importantly, you need it to be flame retardant, because you do not want a chemical runaway in the battery affect the vehicle. Therefore, you need electric isolation, thermal conductivity, the ability to cool well, and all of these materials that we spoke about earlier, the polyamides, PA6, PA66, PA610, or polythamides like PPA, and polyurethanes get utilized for this purpose within the battery. Similarly, in charging infrastructure, you need excellent mechanical properties on chargers or on charging guns. They need to have high dimensional stability, because you can understand that something within the car is often at a lower temperature, and something outside of the car, which is experiencing harsh weather outside, can be at elevated temperatures. And therefore, if you're going to pass very high currents and very high voltages from the mating components, it needs to have very accurate dimensional stability, of course, safety and UV stability, because electric vehicles have a lot of connectors and a lot of these parts in a specific orange color in order to signify high voltage. And this orange color needs to maintain its stability even after UV exposure or even after a long usage of the car. And therefore, the durability of color and surface finish is equally important. Similarly, for connectors, you have components and their properties. Connectors, cables and cable management include high voltage cables, low voltage cables, connectors or safety components, and they need to have excellent electrical isolation. And as we spoke about earlier, outstanding flame retardation properties, hydrolysis resistance, because a lot of these components see water. Sealed connectors need to have liquid silicone rubbers, which is another material that we use very, very regularly. Of course, they should not be prone to shorting, and they should not have corrosion, absolute corrosion resistance, and of course, easy processing as we like. And these are the materials that lend themselves extremely useful for the applications that we seek. A very quick word about liquid silicone rubber, being currently used very heavily in automotive applications like mounts, wipers, sealing, gaskets, and hoses. When it comes to electric vehicles, they are extremely useful for use in connectors and electric wiring cables, wiring harnesses, because of their great properties of temperature stability and compression set, as well as very high degree of chemical resistance. So, having spoken a little bit about what is happening in core electrical components, I think it would also be necessary for us to understand what's happening, what's the progress in traditional metals or traditional elements. So, if you see from 2010 onwards till today, 2025, a period of around 15 years, the usage of high strength steels has been increasing progressively, and I would say relatively rapidly in the last few years. So from about 7% in 2010 on a example of a C segment car weighing about 330 kilos at the BIW level only, today we are looking at around 55% use, which has also helped us reduce the weight of vehicles. And what also happens specifically in case of electrical vehicles, and I would like you to visualize this, because the motors are smaller and because the engine compartment is mostly comprised of smaller pumps or embedded electronics parts, etc., the engine compartment is not as filled as with a traditional engine in a ICE engine. And therefore, as a result, when an impulse happens from the front end, you have less obstructions to it, and therefore you need to make the structure a little bit stiffer. And this is one of the challenges that we have to resolve while working on electric vehicles of the traditional format or the traditional body shape. And therefore, how do you do this? It always has to happen with additional use of high strength steels and more stiff materials. And therefore, we see going forward, high strength steel is going to be an extremely important part of making vehicles, whether it is electric or whether it is ICE. Having said that, one other important thing that is happening today is people are moving on electric vehicles. People are moving to something that is called as a skateboard. And if you look at the picture on the center of the screen, that's a representative image of a skateboard. And what is a skateboard? It comprises of a flat area between the wheels of a suitable height so that you can pack most commonly sized batteries, and therefore it becomes like a flat pan for placing batteries properly. And this helps people, this helps vehicle engineers such as myself to package the batteries in a very uniform manner, therefore having weight distribution adequately between the front and rear wheels, and also being able to provide adequate capacity within the cars. Now, when this happens, please understand that you are seeing a ladder frame structure. Now, in case of a crash, the crash could happen either because of a side intrusion or because of front intrusion or because of a rear intrusion. Therefore, you need to make these sections quite stiff. How do you make this section stiff without increasing the weight of the car? And you would need to make them very stiff because immediately beyond these sections is the battery, and you would like the battery to not sustain any damage as far as possible. So you see that we are currently working with aluminum extruded sections. This is how the industry works today. Aluminum extruded sections of the way that I have shown just above the skateboard are capable of absorbing, deforming, and therefore absorbing a large amount of energy, whether it comes from the sides or whether it comes from the front. And therefore, they are an excellent solution which provides us significant amount of stiffness, but not its compromises in terms of weight on the chassis. The second thing is when we look at the rear portion of the sheet metal which joins the right wheel with the rear wheel. In a traditional car, you will find that there are a number of panels, and these number of panels make up an assembly to become that piece which joins the right wheel with the left wheel. Now, in traditional cars, this would mean that the sheet metal needs to have a lot of tools in order to make these individual parts. It also needs a lot of investment in fixtures, in welding guns, in order to make sure that all of them can come together with the right level of integrity and with the right level of geometry. Uh, in order to avoid this, a new trend is to sort of make the entire rear portion of the car in a cast aluminum, a hybrid casting solution, which is called as a variostruct technology, and therefore make it a steel aluminum hybrid and save on weight as well as provide significant amount of stiffness and rigidity to the rear end of the car. And at the same time, it also makes manufacturing extremely easy. So these are solutions that are innovative solutions that are currently being worked within the industry for achieving the required degree of flexibility that we need to have. Of course, the use of plastics has also grown. Today, we do bumpers, we do a lot of dashboard-like things, and we do trims in plastics. But on some vehicles, we are also experimenting with plastic fenders, plastic tailgates, in order to lightweight the cars, and a significant amount of lightweighting can be achieved. But the challenges remain in terms of managing differential thermal expansions and some level of cost impacts. We are also experimenting with coatings on windshield to block UV rays. Now, I wouldn't be able to tell you the chemical compositions of these coatings because very often these happen to be patented technologies, and therefore the formulae are not out in the open. I wouldn't know them either. But essentially, these coatings are used for UV rays blocking, and which in turn reduces the greenhouse effect and reduces the load on HVAC, leading to a better efficiency at the overall vehicle level. There are body paints and coatings which we also use in order to minimize the drag and provide a superior aero performance. Again, these are efficiency improvement techniques. Now, these efficiency improvement techniques become really, really important on electric vehicles because, as I said, every watt of energy that you can save is every watt of energy that you can give for traction and therefore improvement of the range. And that's what we want, because range anxiety remains one of the higher problems or higher challenges with electric vehicles. I've just listed down a few examples of how future cockpits are going to look like. The challenges or the key parameters that we would work on are in terms of light management. How does the display bond itself to the rear substrates? We would also want to, from a human perspective, look at blocking electromagnetic interferences. Most of these displays are fairly energy intensive. They consume a lot of energy, which is either given out in the form of light or given out in the form of heat, and therefore thermal management becomes an important part. As cars become more and more intense, more and more integrated, cushioning and damping of these various parts coming together is very, very important. And because of the refinement levels of that are imposed upon us, expectations of customers are very high today, and therefore we need to provide the right level of solutions to make sure that any mating parts do not squeak, do not rub against each other, thereby creating an unpleasant experience. And there are any number of solutions today for being able to do that with companies like 3M, companies like Dow and BASF providing these kind of solutions. Now, this is a very so I have explained to you how materials get used, but one of the things that our industry is today facing is how do we preserve and extend what is already used, already made, and this is where we get into recyclability. So there are impending rules, impending regulations that are coming in terms of how do we recycle. In terms of lithium-ion batteries, for example, as we go further and electric vehicles become more commonplace, the question will arise whether we can recycle these materials properly in order that we do not create toxic waste and we do not pollute the environment more than we can save it. And therefore, these regulations come in. We typically talk about this as second life use cases, and the three things that the industry looks at is reuse, repurpose, and recycle. So reuse is to use it in some secondary application. Repurpose is to try and make something else out of a vehicle battery. For example, you could make lanterns, or you could make it into a stationary storage devices. And of course, recycle is to break it down completely and urban mine, so to say, those materials. So these are some of the key elements of the circular economy that we are looking at. Of course, preserving and extending what we already have made, trying to use waste as a resource so that we can make something else out of it. This is already becoming a business model. Some recyclers are getting into it at a massive scale, and because of the mandate or because of regulations coming in, this will turn out into a big industry sometime in the near future. Of course, this forces us to look at designs in a specific way. It forces us to think, how do we look at materials? How do we look at our designs, components in a way that we can recycle them more easily, and incorporating digital technologies. For example, a lot of these technologies, particularly on the battery today, are blockchain enabled to make sure that you can trace and you can understand how the battery is going through its entire life cycle. And we are collaborating with a lot of people to create joint value. So this is how we are trying to ensure that whatever has been created can be does not need to be wasted. It can be reused and repurposed. And then, of course, I would like to tell you that, share with you that Nexon EV was the first Indian EV model which meets the upcoming Indian end of life regulations. And I think the entire engineering team at Tata Motors did a great job by not only launching the car in record time, but also making sure that all the future regulations were met. And we are very proud of what we have done. So we are at 93% recyclability and 96% recoverability. That is a phenomenal achievement in such a short time, right? So that's what it is. I think that's what I had to share with you. I'm pretty sure that you may have found this pretty interesting. But if there are any questions, and I can already see some questions come through, so maybe we can take a few questions now. But thank you for having given this opportunity to come and share with you on various aspects.
Thank you, Anand. That was firstly, thank you very much for that wonderful presentation. I think it was really, really well done. And when I say this, I'm also in some sense echoing some of the feedback we have been receiving, or I have been receiving from the backend team as they are scanning the chats and the feedback parts of the conference platform. So great job by you and your team in kind of articulating what you wanted to present. Wonderful. Before we get into the questions, I also want to just make a few comments that I think from the point of view of presentation. The first one is, some great ideas you have presented. For example, the point that you made on offsetting the impact of our current power situation, in the sense, the power mix, so to speak, by the fact that it is more than offset by the efficiency improvements that you are getting by moving from IC, is probably an argument that I have kind of heard probably for the first time, though it's being made, but I think in such clear terms, it's probably one of the finest arguments you're making for moving into the EV space, irrespective of whatever is happening in the decarbonization phase of the power system. So that's one. Second is, I think for the first time, at least in an Indian context, we have seen you run through the EV discussion, taking it across the full gamut of life cycle, and by bringing in end of life and including the concepts of circularity and such kind of things, which I think also indicates how all our automotive colleagues are thinking about bringing in future forms of mobility. So frankly, these were two important items. So it gives us, as material engineers, it also helps us to bring to put everything in the right perspective, finally, about getting rid of carbon in everything that we do. The second piece, which I kind of liked, and I think that's probably what the audience also must have seen, is how you have brought in not just materials and not just design, but the aspect of collaboration across everything in manufacturing, assembly, and how ultimately, if we want to make progress, there needs to be, even with the existing materials and with the future materials, we can do a great by collaborating and redoing our entire manufacturing assembly systems, etc. I think that was a great point that you mentioned through a couple of slides in terms of how you integrate everything to make a vehicle that is world class. The third point, which I think also it was interesting, and this I'm talking as a consumer, as a customer, was also the points that you made on what to expect in the future vehicles of Tata Motors. And I think not just for us as people who are connected today to give them food for thought in terms of what they need to be doing to collaborate with all the EV manufacturers, but also as customers, what to expect in the future vehicles is something that I thought was quite interesting. And so thank you very much to you and your team who has put together this thing.
Thank
Now,
you.
let
Thank
me,
you.
yeah. So I see that there are a number of questions. Rather than try and moderate them or to change them, let me go with it because I think you have piqued the interest of the audience quite a lot. So let me just go the way it has been constructed here for the purposes. The first thing, and we'll go in the order as it has come. The first question that came up from one of the participants is, do you think the Indian automobile industry can take net zero target by mid-century? The way you've seen it, your points of view, Anand.
So, it's a very daunting target. Let me say, it's a very daunting target. We've taken, or we are making some initial steps towards it, and I think we have made the right steps or initial steps in the right direction. Whether we would be able to do that by the middle of the century or a little early or a little later will depend on how we are able to move forward in the next 5 or 10 years with respect to electrification, with respect to a whole set of other technologies that we are working on. But it would be a good target for us to achieve that as soon as possible. And I hope that we should be able to get to that point before the middle of the century.
Great. I think that's being quite bold, saying that before the middle of the century, you're going to be net zero. And for a country like India, that would be a great achievement. Thank you, Anand, for that confidence to the audience. The second point is, I think people have still not forgotten your Nano. So they are saying, we love the Tata Nano due to its weight and capacity ratio. Can we expect Tata Nano to come back in an EV avatar? I don't know whether it is confidential or otherwise.
Thank you. No, thank you for that comment. I mean, the Tata Nano is indeed something that creates a lot of passion and a lot of interest to everybody within the Tata group. I think it would be very difficult for us to say that the Tata Nano would come back in the same avatar. But let's look at the concept of Tata Nano, and the concept of Tata Nano remains equally valid, more so in terms of electric vehicles. And I think as a concept of Tata Nano, coming into electrification would probably be a safer bet than to say whether the Tata Nano would come back, itself would come back.
Okay, thank you. The next question is, I'm just reading it out. Typically, Indian OEMs have been focused more on fast adoption than being an innovator or a game-changing innovator. Do you see that changing in the coming years? And I think Tata Motors is a good example, if I may, in terms of how we have innovated in the Indian context. Safe, light, and I would dare say cheaper EVs for the same power and capacity ratio. So, do you think this change happening in especially in the Indian automotive industry or the
I,
future
I would
mobility?
I would definitely say that. See, because if we were to be fast adopters only, I think concepts like Indica, concepts like the compact sedan, concepts like the Nano, the Ace wouldn't have come through. I mean, these are products where we literally created new markets, new segments. And even if you look at the Nexon EV or the Tigor EV that we sell, these are products that have created new segments. These are, and how do you create a new segment? You essentially tap into unsupported, unsupplied, unaddressed requirements within the market, and Tata Motors has been excellent in doing that, as some of these products would have shown. We've done this on the footing of having excellent safety record. Our cars being excellent with excellent space, excellent ride comfort. And if you look at it in the recent past, starting from 2020 last year, we've had this range of Forever Young, the new range of absolutely fantastically designed cars, which nobody else within the Indian automotive industry has today. And that's seen in the response that our products have had in the recent past, despite COVID, despite some other things. So I think going forward, you will get to see more of such exciting products from our side. And I think that will put all of us in a significantly good position.
Yeah, true, Anand, and also wishing you good luck also on that. At the same time, great products and underlying great technologies that are homegrown. I think that's what you were kind of alluding to. Thank you
Yeah.
on that. Yes. The other question, I think it's kind of answered. It was about weight increasing. What's the future of steel SKUs? You kind of mentioned that the increasing use of high strength steels and going up to a level of 55% is what you have shown. I would imagine it would even become better if we are able to find some solutions for which you are currently considering aluminum or aluminum composites and aluminum hybrids. And the steel industry is working on making that transitions for you to make it better, including batteries.
Yeah.
Okay, so let's get to the next question. How do you see the supply chain reshaping post-electrification of vehicles? Are battery technology suppliers going to have more say in the designs, or is it going to be with the automotive company or the OEMs?
So there is no doubt that battery companies cannot sort of dictate how vehicles will be made. Uh, and you see, there are any number of battery manufacturers today in the world, and they are restricting themselves to making sure that they can service requests or demands from automotive companies. Depending upon the usage, a large number of formats and a large number of energy capacities of batteries are already available. So it's like a super mall out there. You can go and pick whichever battery suits your purpose, whichever battery suits your requirement, and therefore all of them are into it. I think more and more automotive companies are wanting to do bespoke developments for themselves, because each one of us has a very strong idea about how we are going to service our customers' requirements. And therefore, how to package a battery, how to make the entire vehicle configurable, how to customize it is something that we would still retain core to ourselves. I don't think, in fact, if at all, it's all getting more and more closer together, so that we hold more of the value chain, and we would want to do designs of the batteries, not of the cells, mind you, but designs of the batteries, so that we can hold it together.
Right, got that. I think that's an important point for people to consider. You can get the batteries kind of off the shelf, but to configure them and to create it and to integrate it into the platforms and the designs you want to is where you would want to score over the others, right?
Right.
Right. Thank you. Yeah, that was a good point. The next question is, I think that's probably the last question here. How is Nexon EV planning to cut down on charging time? It is currently charging to 80% in 1 hour in the fast charging mode. Your views, please.
So you see, almost all the vehicles today will have a fast charging time of 1 hour. That's how we configure it, because we've done a lot of surveys, and this is always a choice. This is always a decision that any automotive engineer or any automotive development team makes. So if you look at what kind of power is available, what kind of journey stops do people make, 1 hour is considered to be a safe enough thing. And could we do it faster? Answer is technically yes, but then you would also need faster chargers to come in place, and that would need a whole lot of infrastructure development. Plus, you would need to also it's a question of whether you need density of chargers or whether you need speed of chargers. And I think in the initial phase of development of any electric vehicles, it is the density of chargers which is more important, because that encourages people and that allays fears about whether I'm going to get a charge or not. And that's what we have gone for.
Okay, thank you, Anand. If you are okay, there are a couple of more questions, and I think we could at the end then close. If you are okay with another 2 questions.
No problem.
All right. The first one is recently Tata Motors launched its EV in the commercial segment as well. Can you shed some light on that, like the life cycle of the vehicles, the infrastructure required, as well as the costs of the models, future opportunities as well?
So we have a Tigor ER is what we call it, extended range, and this is a 213 kilometer certified range vehicle. In real life, it will probably be able to give about 165 to 170 kilometers, and this has become a big vehicle of choice for fleet applications. This is a low voltage system. The charging infrastructure is based on what we call as GB by T standard. So it's slightly different. And for large fleet owners, Tata Motors helps them set up their own infrastructure so that they can have the charging equipment. But also public chargers are available, set up by Tata Power and some private players as well. And this is becoming a vehicle of choice for a lot of people, particularly in the fleet applications.
All right, thank you. There's a question on magnetic materials. So magnetic materials like soft magnetic composites, SMCs, are being used widely in high frequency applications like electric motors, as you know, rotor cores, etc. What's your view on these SMCs and the development opportunities in India?
Well, to be honest with you, I may not be in a position to answer that, because I'm not a real expert in exactly the kind of material that might be used on motors per se. We use on our motors, they are permanent magnet motors, because they need to have a certain energy density and certain response times. So I may not be in a position to comment on the SMC materials. Sorry.
Yeah, right. So the current permanent magnet motors are kind of meeting your efficiency requirements also, right? They're upwards of, I think, 95, 97% today in terms of conversion.
Yeah.
Right. This is a little interesting one. It is about, and in keeping with the overall, the conference theme, it's on startups. The question is, how could startups contribute to Tata Motors in its EV programs? And does Tata Motors welcome startups to participate in your EV programs?
Oh, absolutely. And we are working with a few startups. These people are typically in the areas of charging, solutions for chargers. They are also in the form of working on some efficiency related improvements. And there are also startups which are working along with us for alternate powertrains as such. So, in fact, some of these people are not necessarily based only in India. We also work with some startups which are offshore, and we definitely welcome people. Of course, we would need to have the core point of these startups to sort of dovetail with something that we are already working on, but we absolutely welcome startups.
Okay, thank you. I think whoever raised that question is probably free to write to you and to see if you can collaborate with those people who are out there and who might have some great ideas.
Sure.
So I think I think that's all we have as questions, Anand. Is there something else you want to leave the audience with at the end of the session? Anything else you might want to add in terms of how you see the future, or what you can expect from Tata Motors as a leading company in the electric mobility space? Leading company, sorry.
I would only say that we've made a beginning. We made a beginning amongst a lot of uncertainties that we were facing about how we would be received, how would customers receive our products, etc. But I think the welcome or the response that we've had on the Nexon EV has been nothing short of stupendous. And this is a big encouragement not only for Tata Motors but also for the electrification, because ultimately it is something that the country needs. And we keep working on numerous products. You will shortly hear from us making some announcements on that, and we will meet more and more requirements of customers. I thank you, Rajesh and team, for this wonderful opportunity today. I'm just going to use this opportunity to also gather some information from all of you, because I guess we are a very large team today. A very large group group is attending this entire conference. So there are a few questions that we would have for if you would please respond to, and that would help us, with our decisions in the future. Also, as a customer, how would you look at electric vehicles? So do take a moment, and if you can respond to that, it would be fantastic.
Yes, Anand, I believe these questions that you wanted have been sent out as polls to the participants. And
Lovely.
if you, while we will send it to you formally, let me just take a couple of moments to let you know what we have heard from our audience. Your first question was, what's the most important factor for the development of the EV ecosystem? I think that was the first question, to which 66% of the people have responded saying it's the EV charging infrastructure. And maybe later we can have a chat on, there was a question, or there was a point of view yesterday that came up on the EV infrastructure, and why some of the things that we are talking today in terms of infrastructure is not really what we should be looking at, and how we can manage with a much smaller infrastructure if people decide to change their own views on what kind of vehicles they need to own.
Right,
so maybe that
right.
was a great point of view that came up yesterday. The second question was, what's the most important feature you would like in your EV? This is a little bit, spread out. The top one was low charging time, in keeping with the, I think, the convenience part of it. It was about 37% of or the audience polled to say that it is low charging time. That's one of the most important feature. Followed very closely with the mileage, as you would expect people to talk about great mileage. Kilometers per charge is what the audience has responded to your questions.
Lovely,
so the rest
lovely.
of it we will
I
try
would
and
love
route it
to
to you.
look at what people have said. It is always very nice, very good to hear from people as to what they want, because that helps us a lot. Thank you.
Sure. So thank you, Anand. Thank you once again. Great pleasure to have you with us this afternoon.